All right, happy Wednesday. This is on the plans for Wednesday. You'll notice that I'm wearing the same outfit as Monday, Tuesday, and Thursdays because I'm doing these all on Sunday. All right, but this is how can we observe chemical changes, and this chapter accompanies this sheet. All right, so you should have this in your packets. How can we observe chemical changes? All right, so this is something we've touched on off and on all year long, chemical and physical changes, and it's such a big part of chemistry. Okay, so hopefully this should all be like, oh yeah, I remember we talked about this with this and with this. All right, so think of the last time you saw a cooked egg. What happens to the white of the egg? Why? Now think about the rust that forms on iron if it's left outside in the weather. What material combines with the iron to make the rust? Look at the apple in the picture below. Yes. Have you seen that happen before? Why does this change to the apple occur? How can you prevent this from happening? Lemon juice. Is this a chemical or physical change? How do you know? Chemical changes. Why do bananas turn brown as they ripen? Why do apples get soft brown spots if they're dropped or mishandled? As you will see, chemical changes are responsible for many of the changes that you observe every day. Although many of these changes can be observed with your own eyes, a chemical change is a process that occurs on a molecular scale. You know that a chemical change is a process that alters the composition of atoms or molecules, or makes new substances that have different properties from the original substances. So, let's look at them forming new substances. Is baking a cake a chemical change? A chemical change alters the composition of one or more substances to form new substances. Changing the number of atoms or the type of atoms in a molecule is an example of forming a substance. Changing a substance to this extent involves breaking and making chemical bonds. Okay, so here's the lab that we did with the pennies, right? Remember that? So, for example, a new substance can be made by combining sodium, Na, with chlorine gas, Cl, to make the compound sodium chloride, NaCl. In this case, new chemical bonds are formed between the sodium atoms and the chlorine atoms. New substances can also be formed by breaking bonds. For example, mixing sodium chloride with vinegar breaks the bonds between the sodium and chlorine atoms and makes a solution of hydrochloric acid and sodium acetate. Recall that the process of making or breaking chemical bonds and rearranging atoms and molecules is called a chemical reaction. Wow, that right there. So important to know because we're going to be getting into lots and lots of chemical reactions. So, chemical reaction, the making or breaking of chemical bonds and rearranging atoms in the molecules. So, a chemical change is the result of a chemical reaction. Here are some examples of chemical reactions or chemical changes that we can easily observe. Spaghetti cooks in boiling water. Wood burns in a campfire. Milk spoils without refrigeration. Rust forms on an old bicycle. Think about your everyday activities. What chemical reactions have you observed in your time at home today? Can you think of more examples of chemical reactions that you observe every day? Chemical changes or chemical reactions make all parts of your day possible. A common chemical reaction is a combustion reaction. In a combustion reaction, molecules of a fuel source combine with oxygen to give off carbon dioxide and water. Combustion reactions, such as burning fossil fuels, heat water to make large amounts of steam to run generators that give us electricity. The cells in your body carry out combustion reactions so that you get energy from the food that you eat. A combustion reaction is a chemical change that can be easy to observe. A burning candle is an example of a combustion reaction that gives off both heat and light. The candle wax is reacting with the oxygen in the air. During that reaction, the bonds between the atom in the wax are broken. The carbon and hydrogen atoms in the wax combine with molecules of oxygen in the air to become molecules of carbon dioxide and water. Which is crazy. That's so crazy to think about. That's how a candle works. chemical changes and properties of substance. What is the same about all chemical changes? They are all reactions that form new substances. This means that during a chemical change, the properties of the substance that form are different from those that the substance started with. Can you think of some physical properties of substances? Every pure substance has both physical properties and chemical properties. As you know, physical properties describe how and when a substance changes physically. For example, the boiling point of a substance describes the temperature at which it changes from liquid to gas. Also recall that a chemical property describes how and when a substance changes chemically. For example, a chemical property such as reactivity to water describes how a substance changes when exposed to water. Other chemical properties include reactivity to oxygen, reactivity to acids and bases. Rust forming on an old automobile is due to a chemical change in iron. During this chemical change, the iron atoms in the metal parts combine with the oxygen molecules in carbon dioxide and water in the air to form iron oxide. You know iron oxide as the red-brown flaky substance called rust. Right, this is our lab for tomorrow. Get excited. So, look at the table of substances and properties. These individual elements, sodium and chlorine, have properties that are different from the properties of a compound that combines the two elements together, such as sodium chloride. How are the properties of carbon and oxygen different from the properties of carbon dioxide? Okay, so we can see sodium, chlorine, carbon, oxygen. Yet when sodium and chlorine join together into sodium chloride, they become a white solid. They'll dissolve. They're unreactive. Look at what happens to the melting point versus when those two combine. Carbon and oxygen forming carbon dioxide. Carbon going from the dark gray solid that y'all were grinding on your desks making a powdery mess with to becoming a colorless gas, all from its reaction with oxygen. Pretty crazy. So, indicators of chemical change. You know a chemical change is occurring if there are indicators of it. Many chemical reactions can give off heat, light, or gas. Chemical reactions can also form solids out of a solution or cause colors to change. So do you think dyeing a white t-shirt blue is a chemical change? How about painting a white wall red? Color change is often the result of a chemical reaction. However, some color changes are not from chemical reactions. For example, paint is different from a dye. Paint contains a mix of pigments that make up a specific color. Paint simply covers an old color with a new color, so it doesn't require a chemical reaction. Dye is a chemical color that bonds to a surface and requires a chemical reaction. Dyes must be carefully applied to a surface so that it properly reacts and bonds. Many of the colors in textiles are made by treating the surface of the fabric with a chemical dye. Some chemical reactions change the color of the starting substances as new substances are formed. Often scientists take advantage of color change by using the substance as an indicator dye. For example, the acidity of a solution can be measured with an indicator dye that changes color depending on the acids or bases in a solution. An indicator dye must change color in a predictable way. This means that the dye changes color only when a specific substance is present. Do you think an indicator dye changes color when it's added to a solution that it's not specific for? So if we look up here, this pH scale, our indicator was that stinky cabbage juice. Remember that? And we had all of our color changes that happened because of that indicator. So pH strips are another type of indicator. Remember, we used these when we made the soap to make sure that our lye was safe and ready for us to use so that it wasn't too acidic and harsh. All different ways of indicating what type of chemical changes have happened. A precipitate. A precipitate is a solid substance that forms in a solution as a result of a chemical change. Precipitates form because the new substance is insoluble in the solution. The appearance of precipitates can vary depending upon the chemical change. Some precipitates appear as a cloudy substance in a solution, while others appear as a bright color forming in the bottom of a solution. So when a solution of potassium iodide is added into a solution of lead nitrate, a chemical reaction takes place and a new yellow substance, lead iodide, forms. That's the precipitate. So that's kind of cool looking. I don't have those ingredients for us to use in our science experiment, I'm sorry. So take in the picture and appreciate that. Gas, light, and heat. If you put a clean iron nail in a solution of acid, you can observe tiny bubbles forming on the surface of the nail. Iron reacts with acids and gives off hydrogen gas. The tiny bubbles are hydrogen gas. Bubbles are an indication that a chemical reaction is taking place. What are other examples of chemical reactions that form bubbles? Light and heat are also indicators of chemical change. When you see a substance ignite, burn, or glow, it's a sign of a chemical change because some types of chemical reactions produce light or heat. Have you ever used a glow stick? Or a hot pack? Glow sticks contain substances that do not glow until they react with one another. When you snap a glow stick, hey look, I got one. When I snap, wow, it's really hard to snap. When you snap the glow stick, oh, got it. Woohoo! When you snap a glow stick, the substances combine and the stick begins to glow. The stick glows because light is released as part of the chemical reaction between the substances. Hot packs, or like hand warmers, are similar, but when the substances combine, they produce heat instead of light. Do you think burning wood in a fireplace is an example of a chemical change? Why not? How could that be different from my glow stick? Comparing physical and chemical changes. Imagine you're heating water on a gas stove. A tea kettle full of water sits on the flame of the stove. The water starts to boil and makes steam. Describe what physical and chemical changes are occurring. Remember that in a physical change, the material or substance does not change into a different substance. Examples of physical change include change in state, such as boiling, melting, and freezing of water. During a change of state, the atoms in the substance remain in the same chemical bonds in molecules. Physical changes do not change the arrangement of atoms in molecules, and the substances do not change their chemical properties. In a chemical change, though, the chemical properties of substances change, and in many chemical changes, the arrangement of atoms in the molecules change to form entirely different substances. So this top illustration here on the right shows atoms and molecules in a physical change. So we know that they start moving and they get more energy because of the heat, right? But this bottom illustration shows atoms and molecules in a chemical change. So we've got our hydrogen and our oxygen all of a sudden becoming H2O, water. Okay, so look at the difference just between these two, right? So we've just got they're staying in their same state versus becoming a totally new change because your molecules are rearranged atoms. So, in review, chemical changes tell you how and when a substance changes its chemical properties. Because a chemical change is the result of a chemical reaction, it makes new substances out of the starting substance. You can recognize a chemical change by observing indicators of a chemical reaction, such as change in color, formation of a precipitate, or the formation of gas, light, or heat. Chemical changes are different from physical changes because chemical changes alter the arrangement and bonds of atoms and molecules, while physical changes do not alter the composition of substances. All right, so this worksheet, like there's the diagram we just looked at, goes with this lesson. And if you want to pause the video, these 5 concept check questions are an extra credit opportunity for you. Okay, so if you'd like to earn some extra credit points, you can pause and do these 5 questions on the back of this worksheet. All right, so hopefully you're all ready for some fun chemical changes, and for our lab demonstration tomorrow. All right, have fun.